Good afternoon, everybody. You have almost done it. We're almost there. Welcome to this afternoon's discussion on Agile enablement and removing barriers to be successful with Agile. Joining us today, we have Paul Smith. He's a director within CA Technologies Continuous Delivery Unit. Paul has over 20 years of experience in working on integration projects with both public and private sector clients, and really has a strong background and acumen with Agile Development and DevOps. So I'm going to provide value by getting out of the way and letting Paul jump in. Thanks.
Hey, thanks, Keith. Everybody can hear me okay? All right, great. So thanks to everyone for being here today, and let's go ahead and get into the meat. So I want to take some time and just kind of level set on Agile and what Agile means. Can I see a show of hands? Who's actively involved in Agile projects right now, or your team's starting to look at Agile, right? Almost everyone, right? That's the way the world's moving. So again, you know, as this says up here, Agile is a set of principles. It's a way of doing things. You know, we're biting off chunk sizes of deliverables rather than, you know, the big waterfall 6 to 18 months kind of release process. It's a way of thinking, right? I mean, I was talking with some people today. It's not only a way of thinking of how we do development, but it carries back into contracting and procurement, and, you know, how do we procure and contract for Agile? You know, focuses more on individuals than process, right? More collaboration needed. And my favorite thing is, so a lot of people think, well, Agile, we're just doing things really fast. You know, we don't have to do a lot of designing and planning. And one of my favorite quotes down here from Dwight Eisenhower, plans are worthless, but planning is everything, right? So Agile doesn't mean that you don't plan. You know, we still have to do that planning. It's just on a shorter cycle. So a couple of different methodologies you saw on the last slide. Scrum, Kanban happen to be the two that I see most prevalent, especially within government. And it's really important, right? Testing is, you know, very integrated into Agile, right? We want to code, build, test, code, build, test, code, build, test, very iteratively. Until we get the green light and we can actually move something out into release. But it's very important, right, that we're testing at every step along the way, and testing is included, you know, in our Agile sprints. That's where things like continuous integration and continuous build come in to help us. And how do we measure progress in Agile? It's measured using what we call a burn down chart. Right? And that burn down chart is, you know, how many sprints is it going to take us to burn down all the user stories until we've actually rolled out all the functionality that the business is looking to get out there, right? So whatever we don't burn down in a particular sprint, that gets recycled back into our product backlog, or what we call technical debt. So just wanted to take a little bit of time and do kind of a refresher on Agile, just to make sure that we're all on the same page. So the hurdle to Agile, right, constraints. And anybody who's been a developer for any amount of time has probably run into these types of constraints before. System constraints. You know, I've got a piece of code that I'm developing, but that piece of code has to integrate to this back-end system or to this mainframe system, and it's just not available for me. I either don't have the environment, or I'm waiting on the environment to be provisioned. Data, I don't have the right data, right? It's not synced up, you know, one database with another database or a back-end legacy system. The data's not synced up for me to actually do fully integrated testing. Cost constraints, that's usually working with like a partner agency or a third party, where I have to wait on them to stand up an environment for me. And development constraints. And so if we look at a VOC report, a market analyst report, taken back of January 2015, we'll see that over 80% of the teams experience delays in development and QA due to unavailable dependencies. right? We're waiting on environments. 56%, critical dependencies are unavailable when they need them, right? So again, I'm either waiting for another team to deliver something that I need to communicate with or integrate with, or those systems aren't available. And then 79%, restrictions, time limits, or access fees on needed third-party services. How many of you guys know who Jez Humble is? Anybody heard of Jez Humble? Okay. Who has not? Raise your hand if you have not heard of Jez Humble. All right, perfect. So Jez Humble, he is really the renowned authority on achieving continuous delivery. He's got thousands of YouTubes out there. He's written books. And continuous delivery is really the successor of being able to do agile development. And so he did some research here not too long ago, and he saw that the number one inhibitor of companies and organizations achieving continuous delivery was the lead time for infrastructure and environments. So environments are a real challenge, right? Having everything there when I need it with the right data so that I can do my job, right? And so let's go a little bit deeper into Agile. If we look at developers, this is pretty astonishing, right? In a developer's 40-hour work week in Agile, across the industry, 15 hours are spent actually coding. And the rest of the time they're dealing with overhead or meetings or waiting on environments or provisioning, all these other things that they're dealing with. So if we look at all the challenges that we face, right? Things that are outside of their sprint boundaries, things that they don't control, integration challenges, again, where I don't have the data I need, the environments I need, environment provisioning, right? Waiting on some team, usually operations, or I've been out here working with California's DMV, and I know they could wait some time for OTEC to provide an additional LPAR for a development or testing team. So those manual processes, and then a lot of times we're just hitting and troubleshooting, trying to find, what's causing the defects in our code. So there's an efficiency problem to achieving Agile. And then effectiveness, right? What's the quality? So I often joke, I said, wow, you can be really agile and crank out the sprints and still not deliver anything, right? So going really fast by itself doesn't get you there, right? It's about going really fast and being safe so that we mitigate the risk of the product that we're pushing out into production for our business users and consumers. So again, untested functionality. How many times do we assume the risk of pushing something out into our next environment or production because we warrant it, an acceptable risk when we really haven't tested it. Non-functional requirements, right? In development, we usually don't have production traffic, production conditions to test against. Again, integration because we don't have systems, and test data, right? Do we have all the data scenarios covered, right, in our environment that we need to be agile and deliver? So how are we dealing with it today, or actually how have we dealt with it for the last 3 decades? Well, one is we build stubs and mocks. I've built a couple of thousand stubs and mocks in my development career. None of them provided value to the quality chain, right? They were just a simple stub or mock, very simplistic, and I love the picture of Jenga here because it says it all, right? It really didn't provide any value whatsoever in the quality chain. We wait, right? We wait for operations to stand up the environments, the other systems that we need to test against. And again, we can waste money, paying for other agencies or parties to stand up environments that we can test against. And so we really do need to be innovative. If we want to get over these hurdles and achieve Agile, we really need to look at innovative technologies. And that brings me to service virtualization. And by the way, when I talk about innovative technologies, there's lots of technologies that help us get over these hurdles. I'm a big fan of virtual machines, Docker, if you've heard of Docker. But service virtualization, I also think, needs to be part of the discussion when you talk about environment challenges and solving those challenges. This is an actual customer quote. I can't do anything until I have everything, and I never have everything. I don't know, did anybody watch the congressional hearings, I guess a couple of years back now, for the Affordable Care Act? And remember all of the integrators that said, hey, there just wasn't enough time to do complete end-to-end testing. Yeah, you remember that, right? I watched them too. Every one of them, we just didn't have enough time to do end-to-end testing, right? It's because they were waiting for everything, before they could move forward and do their testing. So that's why we need service virtualization, all right? And we'll talk about what service virtualization is. Let's take an example. So I'm on an Agile team, and we're going to build out an order management system or service, right? It's a headless service that we're going to make available to the rest of the agency or organization. So the problem is, right, I've got a mainframe, I've got these databases, I've got, a messaging tier, whether it's MQ or, an ESB. I think we're still saying ESB. But all of these back ends, I have to wait for that entire environment to be stood up before I can actually do robust testing against it. Service virtualization is the simulation of that back end. It is the wind tunnel of software, right? So oftentimes I relate it back to how we develop and build aircraft today. And, so how many of you think that the first time a wheel assembly for a 737 is tested is when it's attached to the fuselage and then we take it off the runway? Who thinks that's the way we build aircraft? Who's ever been part of a development project where that's the way we've developed software? Really, nobody? I mean, yeah, okay, a few hands there, right? I mean, so what do they do with the aircraft? They use wind tunnels, they use simulators, they use things that can test that wheel assembly long before it's actually about to be released. And if you think about it, the pilot, same way, right? Everybody remember Captain Sully, right? Landed on the Hudson River. And I often ask, how many times do you think he practiced that? He practiced actually a lot, right? In a simulator, not on the real, wasn't landing on the Hudson, but he practiced in a simulator enough times that when he was faced with the real production type behavior, he was successful at doing it, right? And so when you think of that, I mean, that's what we should be doing with our software development, right? And by creating these simulators, we don't have to wait on anything, right? I've got complete control of everything I have to integrate to in my hands. And I can rheostat and lever it for any kind of data condition, any kind of behavioral condition, performance, all that stuff that we're doing with aircraft we can now do with software. And it fits perfectly in Agile, right? Remember the circle where integrate and test, integrate and test, integrate and test. So today what I see is development, they're really good at integrate and doing unit tests, integrate, do unit tests, integrate, and now it goes off to functional test and systems integration test and then performance test. We should be incorporating that functional, the integration, and that performance test in our circle, right? I mean, that's what Agile is about. It's about bringing people across all those different QA teams into that collaborative Agile team and using simulation as far as we can to improve that product so that when we do that performance test, with all the real stuff, it doesn't blow up in 15 minutes. And that's my experience with performance testing. It usually, for the first time, takes about 15 minutes before we get defects. Real quick, what is service virtualization? Again, I want to focus really, it's about capturing the data, the behavior, modeling it out. But what you end up with is a live-like simulation of the real things. Okay, so it looks, feels just like the real thing. Give you another story at California, DMV. I was here working on a proof of concept, and we had the nicest lady. She was running the front end driver's license application, and I switched her from pointing to the mainframe to pointing to a simulation of the mainframe. And she kept working, and she had no idea that she was actually hitting a simulation of the mainframe until I came over and told her. That's good simulation, right? And that's what service virtualization brings to the floor. Another great quote, right? Because most of the time when I talk to people, they're like, I don't believe it. But, you know, any sufficiently advanced technology is indistinguishable from magic. Great quote. So let's go back to Agile, right? This is actually a real customer story, customer example, the burn down chart, right? So they took their historical data and they matched it up. And using simulation or service virtualization, they had a 33% productivity increase, which means they actually delivered in 2 less sprints. Right? So they knocked off 2 weeks of their final deliverable by delivering more story points. And again, it makes sense, right? Because they can do more testing earlier, right? Which, the next slide, right? If I can do more testing earlier, if I can test edge conditions and those what-if scenarios, I'm now finding defects in unit testing, and they're not being passed on to QA, and on and on and on. And you know, everybody knows that finding a defect in unit testing is a lot less expensive and easier to fix than finding one later, you know, pre-production or heaven forbid production. Nobody wants to find one in production, whether it's, you know, having to go in front of Congress or whether it's, you know, you're a private firm losing a lot of money because of it. But we all want to mitigate that risk. And the way to mitigate that is how do we increase our automation and improve our quality earlier in the life cycle, right? And that's the barrier that service virtualization helps get over with Agile. Says the same thing that I just said, right? These are industry standards here, you know, per defect, how much it costs as you move, you know, closer to production. And certainly we don't want to find it in production. But the more defects that we can find earlier in any life cycle, again, you know, we're going to get more user stories, so we're increasing our efficiency, we're increasing our quality using service virtualization. This is also in that market report I referred to by Voke. The cost benefits of using service virtualization. Most of it, right, again, was giving them that 24/7 under their control simulation, right? That was the biggest benefit that Voke found for all of the clients that use service virtualization today. There was some OpEx savings. Sometimes that's not as big of a deal for my government agencies, right? Because a lot of times they have all the infrastructure they need. It's just about provisioning and man hours. So there's still some you know, OpEx savings there. And then third-party access fees. And you know, in the private market, right, they actually have to pay, right, to hit another a partner's test environment or development environment. Not so much in the government, but anytime you know, one government agency has to rely or work with another government agency, there's some cost associated with it, right? It can be a real pain. An example there is we did at USCIS. They had to work with US Visit. You know, US Visit is a program when somebody comes in, they immigrate in. USCIS has to do the checks, and then they have to go back and hit US Visit and get that information. And so US Visit has to provide a stable, working environment for them to test against, and they did anything but, right? It was up today, down tomorrow. The data changed the next day. So that instability in test and development environments, of course it inhibits being able to be agile, right? And here's the other one, right? Just think of how many times you had to wait on some group to deliver, that LPAR or that other system, get it up and ready, or the new version, of that application that you have to integrate with. And when you have a simulator, there's no waiting. Might be some, right? Because you might have to add some new data scenarios or testing scenarios, but nothing like actually waiting for operations to stand that up for you. Just a customer quote. The key here, is in purple. Agile parallel development and increasing their quality, and ultimately down here in the bottom, reducing risk, right? And to me, it just makes sense, right? If we can use simulation to do more and better testing earlier in our life cycle and our deliverables, to me, again, it makes common sense that we're going to deliver faster and a better product. Again, so oftentimes when I come in and talk about, whether this technology is a good fit for an organization, I often ask questions, how much time do you deal with setting up test data? You got a 10-person team, you're running 2-week sprints, you calculate the hours, and they'll say, we've got 4 people spending, 2 days each setting up test data, right? You could do the quick math, right? Take your wages times the 4 people times the hours, and you figure out that, right, that's how much you're spending on setting up test data. What if you can knock that down by 90%, right? And it's about reliability and predictability. That's what testing is all about, right? It's that I'm going to inject a test into my system, and I know I'm going to get reliable, predictable results back, right? Otherwise, if I don't, I get, false negatives and things, because the data's not synced or the data's changed. I use the example, I want to test closing a bank account. So I say, okay, close Paul Smith's bank account, and it comes back and says, you've successfully closed it, and that's my test, right? I want it to come back success. So it worked, passed the test. I want to test it again. So if I say, close Paul Smith's bank account, it's not going to come back with that same answer, right? Because it just got closed. I have to go and do a reset on the data, right, to get that same condition, not with a simulator, right? I'm always going to get that reproducible, reliable, predictable result, okay? A customer I have in the private sector, they're a phone company, which will go nameless, but I kid you not, they had basically a book of account numbers. And they would start with the first account number, and they would try to go through a workflow, and then if it didn't work, they'd come back and they'd take the next one, and they would really just manually go through until they found an account number that allowed them to test the complete flow, because they had no idea on the data synchronization and everything. So they use this today to make sure that all that data back there is synced up, right? And now they just push buttons, and the regression testing is automated. We talked about availability and the cost savings. And again, these are all real customers that use Service Virtualization. There is a website called servicevirtualization.com. It's sponsored by CA Technologies. However, you'll find all sorts of customers, vendors. I mean, it's completely agnostic to CA Technologies, our solution. But it's a great place for you to go out there and really dig in and understand how Service Virtualization can help your environment strategy for Agile. So let's quickly summarize, and then we'll take some questions here. So again, we're eliminating that dependency on constrained environment systems and teams, right? Parallel development, right? Because I no longer have to wait for somebody to deliver their service. I can start testing against it day one. In fact, when I went and talked to the Accenture had come in and taken over for CMS, the Affordable Care Act, and we talked about, hey, you should be able to test right out of design. You should be able to do end-to-end testing right out of design using simulation. And if you can do that, you're going to catch most of your defects really early. So when you start plugging in the real pieces as you're moving to release this out in production, you should find that there's not a lot that you're fixing, because you've already done the rheostat and the levering and the what-if conditions. Non-functional testing, right? Everybody here, I'm sure, has used some sort of load testing tool. Load Runner is probably the gorilla in the market, but there's Java Grinder, going back to development. But that's all pushing load from the front at my piece of software. What about in the back, right? I mean, is that mainframe responding like it really does in production? It's not in development, not in test, probably not until we get almost out to release into production, right? But if I'm simulating it, I can actually simulate all that. I can break my software. And that's really valuable, right? Because knowing the breaking point of software is fantastic. Because then, if my boss comes to me and say, hey, we're going to add another, 5,000 concurrent requests hitting this. Can you handle it? I can tell you, no. We can handle 3,000 more, but, when we loaded this thing up and we did all the isolation testing, this was the breaking point. So we'll need to put some load balancer or something in there to be able to handle that. Again, if you think about using, test harnesses on one side of your software and then simulate the back end, you're being able to test in isolation. Again, I go back to the wind tunnel, right? Being able to test that airplane wing for different angles, for different winds, for rain conditions, for hail. They used to, all the GE engines that go on the airplanes, they used to shoot, this is probably horrible, but they used to shoot frozen chickens into the turbines. That's how they did the testing to make sure that if a real bird flew into an aircraft engine, that the engine would still be able to operate it. I don't think they do that anymore because I think PETA or somebody got involved with that. But that is a true story how they used to test the GE engines. Test data management, right? So test data management needs to be part of your strategy for Agile, right? Whether you're using a simulation where you have virtual test data, or whether you're using a test data management product, or both. I mean, most of our clients, like American Express, most of them are using both, right? They use test data management to pull from production, to get in their pre-prod environments, and then they'll use service virtualization down at the lower layers for development to do that early kind of simulation testing, right? But test data management has to be something that you look at in Agile. Test coverage again, right? Are you covering all your edge conditions, right? Because that's where most of the defects come from, are negative testing scenarios. And again, the end result, increased throughput, which is going fast, but safe, right? Because it's not just good to go fast. You have to be safe when you get to wherever you're going. All right, I'm going to, this is the last slide here, and I'll open it up for questions. But just to give you some use cases where most of the customers I've dealt with, where they really focus on applying service virtualization. I'll try to give you a quick example, a business in a box. So this is where you're the service provider. So FedEx provides a service out to literally a couple of thousand retail vendors. And FedEx doesn't want to keep standing up an environment, a test environment or development environment for them to test against. So what they do is they stick a virtual service out in the cloud. They say, there you have, that's FedEx in a box. Use that, test against that. You can change it if you want, change the data, but there's your test environment. So instead of spending a couple of weeks on standing up these environments, they're putting it up there in a day in the cloud and saying, all right, retail vendors test against this. Integrations is another great place, right? Anytime you have to integrate with another agency or anyone outside of your control, it's a perfect place to use simulation. Again, quality, if you want to push that testing earlier. Because I could tell you, I work with a lot of customers that are talking Agile and doing Agile, I've never seen one of them include performance testing in their sprints. Not yet. So it's still kind of Agile fall. So the developers are doing Agile unit testing, but that's where it stops. With this, why shouldn't we kick off in our continuous integration or our continuous delivery engines? Why shouldn't we kick off performance testing as part of a sprint output? Time to market, okay. Let's face it, I mean, ACA time to market was important, right? Because the president says it's going to be delivered on a certain date. We got to deliver it on that certain date. But it's more about risk for my government customers, right? Just making sure that we're doing as much testing as possible and we're mitigating risk. Training environments, all right? So I finish a product, now I got to train all of my customer service agents, my customer-facing agents. But it's going to take a month for me to get that training environment stood up, and then of course I got to start training them. Why not have a training environment right out of design where you're starting to train them so when the real thing's delivered, they've already been training on it, right? Because it's all, a simulation. It's like a pilot, right? Putting the pilot in, let them train before we put them in the real airplane. And then test data management. As I mentioned, so I call this virtual test data management, right? Where I can actually capture all the data I need to cover my testing scenarios early in development and test. If you need something beefier, test data management products are out there and available as well. So I think I've left, based on our schedule, about 5 minutes for any questions. So I'll take questions. Anyone? Make sense? Yeah? It's pretty simple to understand the simulations, I think, and how they help. Especially developers. I mean, we've created mocks and stubs for a long time, right? And this is just a productized way of looking at service virtualization that gives you more real-world behavior. Again, you combine something like this along with, the Docker technologies or your hypervisor technologies. Now we're really talking about, a solution. Last time I checked, if you have to integrate with the mainframe, I don't think the mainframe's being put in the cloud yet. I don't think there's a hypervisor that we could put the mainframe partition on yet. So there still are those systems, right, that we have to integrate and deal with where, service virtualization could pay big dividends. Yes, ma'am.
Just the first couple of minutes, is there a product that your company sells, or are you sharing the concept and all this has to be built?
Yeah. So that's a great question. There is a product that we offer, but I didn't want this to be product focused, right? I'm happy if people understand the concept and they want to apply the concept, and then go do your homework. There's other competitors out there with similar products. Do your homework, and I'm happy to compete against them and work with you to find the best product. So we do have a product. We sell it, so I would be happy if everybody would buy our product, but that's not the purpose that I'm here today for, right? It's really about providing a little bit of education around an innovative technology that our customers are having tremendous success. I mean, California DMV, I don't want to say any of the names because I don't know if I'm supposed to, but one of the managers over there, this is, before I was a director, I was actually, the guy that was doing the stuff, I still think I'm an engineer, but I don't know, management tends to take that away. But one of the senior managers, he brought us aside and he goes, just want you to know, when this stuff fails, I'm going to be long gone from DMV. He's still there, and they've been wildly successful, wildly successful. The Defense Health Agency, same story, wildly successful. And of course, there's tons of commercial successes out there. I mean, I think commercial's a little bit ahead. and using this stuff, especially around the financial institutions. But it's a big deal. I mean, the government still has a lot of mainframe. You know, I think everybody's trying to move to distributed systems, but I don't know if mainframe's going anywhere anytime real soon. And it represents a real constraint to development efforts, you know, and if we can, I can put a mainframe simulation on my laptop and I can actually code against it and build stuff while I'm on an airplane flying back to Virginia. That's a pretty powerful story, right? And then I can plug it in, and I know there's rules in government agencies, you can't do that, but you know, I can own my desktop, right? I could have when I go into work, I can be testing against the mainframe, and I can rheostat it and lever it, and change the data, change the performance, see how my code works against it, you know? So developers by nature want to build the best code they can. I've never met a developer that wanted to put out crap, you know? It's just that, sometimes the tooling isn't there, right? So you do the best you can, and you push it down the assembly line. And what we're saying is, hey, if you take the time and look at, service virtualization, something innovative, it can really help us deliver better product and actually make us go faster. Now anytime you bring in a new technology, you have to start slowly, right? So it is kind of an impediment, because you got to learn the product. You have to walk so that you can run faster. I've been injured, but my wife and I are on a triathlon club. And the whole thing about triathlons is you run long distances, you bike long distances, you swim, everything's long distance. And the training is all about zone 2, right? And zone 2 is actually almost walking for me. But by training in zone 2, you actually end up increasing your speed to go faster. So that's the way I look at innovative technology also. Yeah, there's always some overhead when you bring in a new technology or a new concept. But if you take the time and you get acclimated to it, it's going to help you in the long run deliver better quality and be more efficient. Good question, though. Anybody else? Yes, ma'am. Yes, I'm going to, the young man back there with the light shining in my eyes has asked me to put one on the laptop here, so I am going to leave it here. And, Keith is local here, and he supports CA Technologies all across the state government. We have a local engineer resource here as well. So we've got a local footprint here that you can get in touch with us, and if you want to dig more into this, we talked about Agile and Service Virtualization today. There's a whole umbrella under continuous delivery, right? It's test data management. It's how do you model and plan for Agile? How do you automate your releases, right? Not just continuous integration, but actually propagate a release from, okay, I get it out of Jenkins, and now I want to put it into my functional QA environment that has 4 servers instead of the 2 that I built, with Jenkins, and then eventually move that into production. And how do I do that? And how do I give visibility across the management of operations? And finally, how do I get to DevOps, right? That's the promised land, is getting to DevOps, but baby steps. Anything else? Any other questions? All right, we'll be around. We have a table if you want to, if questions come up or anything. But thank you so much for your time today.